photoelectric effect? That's the questions that we have in play. So photoelectric effect, we say that is the ejection of electrons. Ejection of electrons from an atom. From an atom on the metal surface, from an atom on the metal surface when electromagnetic radiation electromagnetic radiations or light, right? When electromagnetic radiations or light is made to strike what? It's meant to strike the atom. So let me explain what does it mean. I need a space to explain it. Photoelectric effect. Say it with me. Photoelectric effect. Photoelectric effect. Photoelectric effect. Photoelectric effect. Photoelectric effect. Say it again. Photoelectric effect. Don't ignore, because this is the new terminology for you. What is photoelectric effect? Is ejection of ejection of electrons. It's ejections of electrons from an atom on the metal surface when electromagnetic radiation, this we call it light, is made to strike what? Is made to strike the atom. So suppose that this is the surface of the metal. This is the metal surface. This is the metal's surface. And then you have instant radiation. This is instant radiation. Right? So these are the instant radiations that falling on the metal surface. So what happens? We say that if the frequency of these instant radiations is greater than a frequency, we call it is threshold frequency. Threshold frequency, or we call it wave function. We say that if wave functions of this wave function is a little bit advanced for the you who is studying chemistry, if the wave functions of these instant radiations is greater than the initial wave function, then we say that when this light falls onto this metal, which contains a lot of electrons, and this instant light provide an amount of energy which is enough to overcome the nuclear attractive force that holding electrons in the air position, then we'll find that electrons will be ejected. So electrons will be ejected on the surface of so will be ejected on the surface of the metal. So that process we call it photoelectric effect. Photo effect. And electrons which will be ejected, we call them photoelectrons. Okay? So for the electric effect, we say that is ejection, so is production. Ejection is a synonym of the productions, or is generations, or is a process of producing of electrons from an atom on the metal surface when electromagnetic radiation, means we are using light, when the light is made to strike the metal or fall on the metal surface. But not every amount of light will be suitable for that. That's what we say, that the amounts of the instant light, its frequency should be greater than the threshold frequency, and also its wave function should be greater than wave function, right? Or initial wave functions of the metal that we have been there. And a good example, according to Einstein, is zinc. So zinc plates, this is the good example that are actually providing the verifications of the concept of photoelectric effect. Right? Okay, so if that's the case now, I believe that you are competent in this concept of 40 of de Broglie or wave particle duality nature of electrons. So now let me give you one example, and then you enjoy your evening, or you enjoy your morning, or you enjoy your night. And this is in connections of previous lecture, especially session 8 and session 9. We say that this is example 09, okay? And the questions asking is like this: what is the de Broglie? What is de Broglie? De Broglie. So what is de Broglie? What is de Broglie? De Broglie's wavelength. What is de Broglie's wavelength? What is de Broglie? De Broglie's wavelength. Broglie wavelength for a neutron. For a neutron traveling with a velocity. With a velocity 5% of speed of light. Speed of light, in that we say that the speed, when the speed of light, when this speed of light is given, these are the constants that have been given, 5% of the speed of light. Very important concept. So given this, given the speed of light, this is equal to 3 exponent 8 meter per second, and then the Planck's constant is equal to 6.63 from negative 34 joule second. And then we say that the mass of electron is equal to, or we say is 1.61 from negative 19, so negative 27 kilogram. So these are the data that are being given. The questions asking us to find the Broglie wavelength. The Broglie wavelength. So the questions is simple for my students, because I've already taught you its concept. It's simple, but it's not straightforward. Simple. You have to think a little bit. What is the Broglie's wavelength? That's the Broglie wavelength is required for a neutron traveling with a velocity of 5% of the speed of the light. Given that the speed of the light is that one, means that this is 3 exponent. Let me write it visibly to make it visible. 3 exponent 8 meter per second, Planck's constant 6.63, so negative 34 joule seconds. Mass of electrons is 1.61, so negative 27 kilogram. Okay, so we say that solution, what is required. So we say that, okay, let us start from, okay, that are given. We've been given all the required data. Number one, the questions asked us, the Broglie de Broglie wavelengths. De Broglie wavelengths, in chemistry or physics, we have this notation. So this is what we have to find. And then she said that the velocity, we say that the velocity of neutron, velocity of neutrons, let's say that the velocity of neutron, this is 5% of velocity of light, that is c. And then the big given mass of electron, the mass of electrons is 1.61 exponent negative 27 kilogram. Again, what do you need? Speed of light, will be given that the speed of light, c, because they've already let it, speed of light, so we have let it speed of light, that is c is equal to 3 exponent 8 meter per second. So we go for the second stage. Second stage, we say that you have to record the de Broglie's equation. So the de Broglie's equation say that you can derive, you can recall or you can derive. And the way that you derive, don't just there's two equations that you have to keep in your mind. Is this that energy is equal to Planck's constant frequency, that the Planck's equation, and the other ones I guess is Einstein equation, which is energy is equal to mass times speed squared. And this also you can express that energy is equal to mass times Planck's constant and speed of the light of whatever wavelengths. That's all. So then you equate the two equations. So this is equation 1 and this is equation 2. So no need for you to create. So just you take equation 2 is equal to equation 1. So what will happen? So you have Planck's constant c over wavelengths is equal to mass times c squared. So 1c cancel. So no need for you to create. In this channel, we will never teach students to create. Because even myself as your teacher, I fail to create the stuff. I used to know where should I start. So in this channel, we build a fantastic foundation for you in case of mathematical formula, mathematical equations. Where should you start? At what point should you start to deduce that formula? No need for you to claim 100 formulas in your mind. It will be misuse of your brain, and also misuse of your memory. The point as a chemist or physicist or mathematicians, you have to remember where can you start to deduce or derive that formula quickly as possible. Because you'll be sure, rather than claiming sometimes that you have a guess, you're not sure. So for this equation of mass times sort is this one. So the next step, this is over 1. Then we do what? We cross multiplications, Planck's constant is equal to mass times this one, that's wavelengths. Then we divide by mass, then we divide by what? By mass. So wavelengths is equal to what? Planck's constant over mass of electron for this case, and so it is speed of what? Speed of light. So this is second equations. We say that deduce or derive what? We say that derive the de Broglie's equation. So we have our de Broglie's equation there. So we have to come and read clearly the question. The question says that you have to calculate the de Broglie's equation, and in this case, generally, it is Planck's constant over mass times speed, right? But we are calculating the Broglie's of what? The Broglie's of neutron. What the questions you have calculated the Broglie's of what? Of neutron, not the electron. But the mass of, are we given the mass of neutrons or the mass of electrons? This is the mass of neutrons, I guess. Yes, the mass of neutrons. I'm sorry, excuse me please. I'm sorry. This is mass of what? Of neutron, not electron. Thank you, God, for reminding me. Mass of what? Of neutrons. It's not mass of what? Of proton. So with this one, we say that it will be Planck's constant of a mass of neutron and then speed of neutron. But from the question, you have to remember that the speed of neutron is 5% of the speed of light. Right? So if that the case, you say that the wavelength of neutron will be equal to Planck's constant, then mass of neutron, then times 45% of speed of light. So you see now the concept here. Don't think that these questions are easy the way you think. Maybe in your exam you might be asked that, or you might be told that the velocity of neutron is 10% of the velocity of the light. You have to take it into consideration. So then we say that the speed of neutron is equal to Planck's constant, which is 6.663 times 30 times or exponent negative 34. This is joules second, divided by mass of the neutrons, which is 1.61 exponent negative 19, or exponent negative 27, then multiplied by 5%, which is 0.05, times speed of light, which is 3 exponent 28. So the wavelengths of neutrons will be equal to what? Use your mathematical calculator, and hence you enjoy the beauty of chemistry under that case. So the wavelengths, the de Broglie wavelengths will be 2.74, 2.74, okay, 2.74 exponent negative 14 meter. Okay, so that the de Broglie wavelengths. So we say that hence the de Broglie wavelengths, the Broglie wavelengths of neutron is 2.74 exponent negative 14 meter. Right? So that the Broglie wavelengths. In case you have any question, please ask in the comment section. If you have any question, please ask in the comment section, so that you may enjoy the beauty of chemistry for the rest of your life. Okay? Please make sure that you ask your question as well as you can, so you may learn further and further and further and enjoy the beauty of chemistry. Okay, so homework. It's time for the homework 10. Homework 10 now is around your place. Homework 10. The homework 10 is an interesting question. This is stated like this. Alpha particles emitted from barium have energy of 4.5 mega electron volt. Given that the mass of alpha particle the mass of alpha particle, the mass of alpha particles is what? Is 6.6 exponent negative 27. You see, it's less in mass. And they also 1 mega electron volt. 1 mega electron volt is equal to 10 exponent 6 electron volt. Then we say calculate the Broglie or the Broglie's wavelengths. It's a little bit trick questions. Let me just see. Yes, just like give you a note, like it's like a concept. The question states like this one: alpha particle, you are alpha and omega. The alpha particles emitted from the barium atom. Barium atom, you know that is just like, it's not the elements within the 20 elements in the periodic table, have energy of 4.5 mega electron volt. Given that the mass of the alpha particles is 6.6 exponent negative 27 kilograms, so it obeys the conditions of de Broglie that in order to determine the de Broglie wavelengths, the mass of the particle, or the mass of electrons, or the mass of neutron, or the mass of alpha, or the mass of beta, or the mass of gamma should be small enough so that the de Broglie wavelengths can be computed. It should not be larger like the mass of the stone. And then the 1 mega electron volt is equal to 10 exponent 6 electron volt. So calculate the de Broglie wavelengths. Calculate the de Broglie's wavelengths. I have taught you everything and nothing new there. You have to use the concept that I have taught you in this lecture. So if you manage to solve that problem, you are good. You are somewhere else. Now you can sound like a wave duality nature, well-trained student in this concept. So I would like to thank God always, because He gave me ability to teach you, and even the materials to teach you, the knowledge, the tricks, different tips of teaching you. Because you know that sometimes that you may be singing this song called the atomic structure, then you find that the chorus, okay, you can sing the chorus and then you get lost along the verse. Okay, so I thank God for that. I thank God also for you who has been watching this video from the beginnings to the end, or even if maybe from the middle to the end. I would like to thank you. Make sure that you ask questions in the comment sections. Go to the descriptions of the video. You'll get too much details. In case that you want to order the advanced chemistry books, advanced physics books, all-level chemistry, physics, mathematics books, basic applied mathematics books. In case that you want to order some materials, or you want maybe to offer your Thanksgiving offering, or you see the offerings through this mobile number, and even just in case that you want to know the links for other channels, because in YouTube I have 6 channels. This is one of them. So make sure that you are well informed and you enjoy and you get connected, because in these programs we take you from the O level, from the Form 1 to your undergraduate level, in case that you'll be pursuing the engineering mathematics. So thank you very much. Share this material with your colleagues, with your classmates, with your schoolmates, with your young brothers, young sisters, anybody in the United Republic of Tanzania, because this is the time for the digital technology, and you want to impact the generations that we are living right now, and even the generations that we are living, or the next generations after us. So thank you very much. Join me in lecture 10. This is all about atomic theory. So in lecture 11, so I will teach you about the quantum number, which is fantastic in case of atomic structure. Then I'll teach you about the electronic configurations, and that will be all about atomic structure. I guess I'll take you the bonding, okay, which is very important. Stay tuned, stay connected. I believe that you'll get a lot more than you think in this channel. Thank you very much. This is Olenjolai from United Republic of Tanzania. See you in the next lecture. Goodbye.